Hello. Today we'll be talking about N factor. This N factor is a very important topic there in all the three parts of chemistry, whether it is organic chemistry, inorganic chemistry, or physical chemistry. In every aspect of chemistry, this N factor plays very important role. You know what this N factor is? N factor is oxidation number. N factor is valency. N factor is charge. N factor is acidity of a base. N factor is a basicity of an acid. This N factor is the number of electrons lost or gained during any chemical reaction. N factor means valency. N factor means oxidation number. N factor means charge. N factor means acidity of a base. N factor means basicity of an acid. N factor means the number of electrons lost or gained during any chemical reaction. So these are different ways to calculate N factor. See, first we'll discuss about the valency, oxidation number, and charge. Valency, oxidation number, and charge. See, if we'll take aluminium, then the valency of aluminium is 3. Oxidation number, oxidation number, oxidation number of aluminium is +3. Oxidation number means charge. Oxidation number and charge both are one and the same thing. That is +3. That is +3. That is +3. And what about the valency? Valency can never be plus or minus. Valency of aluminium is 3. Oxidation number or charge of aluminium is +3. Valency can never be plus or minus, but oxidation number or charge can be plus, can be minus, can be fractional, or can be zero. Also, valency can also be 0. Now see, as I have told you, example will be taking aluminium. So see, aluminium equivalent weight. Equivalent weight of aluminium is equal to atomic weight of aluminium upon valency, oxidation number, or charge. You know, equivalent weight of aluminium is 27. So 27 divided by 3 because the valency of aluminium is 3. So to understand this N factor, to understand equivalent weight of different elements, you should know their atomic weights as well as their valency also. Then only you can understand this concept. So equivalent weight of aluminium is equal to atomic weight of aluminium upon valency of aluminium. Atomic weight of aluminium is 27 and valency of aluminium is 3. So this will be 9. So equivalent weight of aluminium is 9. See, in many cases, they are in normality, they are in Faraday's law of electrolysis, electrochemistry. There, this equivalent weight will play very important role. Then only you can understand those chapters. Then only we can do numericals from those chapters, and then only we can do questions. Now see, we'll take one more example to understand this. Equivalent weight of Cu2 plus. So whether you are talking about Cu2 plus or you are talking about Cu1 plus, equivalent weight of Cu1 plus. If it is Cu2 plus, then atomic weight of copper is 63.5. And here you have taken oxidation number or charge 2. So 63.5 divided by 2, that is 31.75. This 31.75 is the equivalent weight of Cu2 plus. In examination, they won't be giving you Cu2 plus, they will be writing CuCl2. CuCl2, C, 1 Cl is having 1 minus charge, 2 Cl will be having 2 minus charge. 2Cl will be having 2 minus charge. 2Cl will be having 2 minus charge. So since this is 2 minus, so this will be 2 plus. So this way you can calculate equivalent weight of CuCl2, or you can say CuSO4, or it can be Cu2 plus. Now equivalent weight of Cu1 plus, what does it means? What is the meaning of Cu1 plus? Cu1 plus means CuCl, or you can say Cu2SO4. So this is 63.5 divided by 1. So that will be 63.5. See here, equivalent weight is of Cu2 plus is 31.75, and here equivalent weight of Cu1 plus is 63.5. So this is what the difference between equivalent weight of Cu2 plus and Cu1 plus is. So here, what I am trying to tell you, you should know the valency, you should know the oxidation number, you should know the charge of any species, then only you can calculate equivalent weight. And to get equivalent weight without n factor, without valency, oxidation number, charge, you can't get it. And then only you can write the right answer. So this is one thing. So what next is to understand this n factor, CH3PO3. What this is? This is phosphorus acid. What this is? This is phosphorus acid. This is phosphorus acid. Now see, you should know the structure of this phosphorus acid also, means you must be good in chemical bonding also. CP, OH, OH, H, and O. This is H3PO3. In this H3PO3, how many OH are there? This is one OH and this is second OH. Two OH are there. So its basicity is 2. Its basicity is 2. Its basicity is 2. Basicity of this H3PO3 is 2. Why? Because only two displaceable hydrogen atoms are there. This hydrogen atom can't be displaced. Why? Because this hydrogen only is polar. This hydrogen is only acidic hydrogen. This hydrogen can only be lost, not this hydrogen, because it is not having polar nature. Why this hydrogen is not polar? Because the difference in electronegativity between P and H is not that much. That's why this H can't be lost. But the difference in electronegativity between this O and H is sufficient, so this H can be lost easily from this OH. Since only two H are there, they are in the form of OH, that is why it is dibasic in nature. That is why it is dibasic in nature. And if you want to calculate equivalent weight of H3PO3, then molecular weight, here it is not an atom na. So here you won't be writing atomic weight. Here you will be writing molecular weight. Molecular weight upon basicity. Acids will always have basicity and bases will always have acidity. So molecular weight, now see this is 3 plus this is 31. 31 plus 3 is 34. And this oxygen is 16. 3s are 48. So it is 82. So molecular weight of H3PO3 is 82 and basicity is 2. So
Sir,
the
can you please explain it once again?
Yeah, just a minute. Once I'll finish it, then we'll do it again. So molecular weight is 82 and basicity is 2. So 82 by 2 will be 41. So the equivalent weight of this H3PO3 is 41. See what I told you. I have said that this H3PO3, you should know the structure of this H3PO3. H3PO3, you can write like this too. POH OH, OH, OH. So if you see this structure, from this structure point of view, three OH are there. So it is tribasic acid. But experimentally it is proved it is losing only 2H, not 3H. So this structure won't be correct. Then what is the right structure of this H3PO3? This is the right structure of this H3PO3. This P is having two OH groups, one H attached to this phosphorus, and one oxygen is covalently bonded with this phosphorus. In this way, this H3PO3 is having only two displaceable hydrogen atoms. How you can say only two hydrogens are displaceable? Because only two H are there, they are in the form of OH. This H is not there in the form of H. H, which is there in the form of OH, can only be displaced. So this can lose only 2H. So that is why this acid will be having basicity 2. Since its basicity is 2, so to get the equivalent weight of this H3PO3, molecular weight is divided by basicity. Molecular weight is 82. How it is 82? This is 3 plus 31. 3 plus 31 is 34. 16 threes are 48 oxygen. So 48 plus 34 will be 82. So the molecular weight of H3PO3 is 82 and its basicity is 2. And its basicity is 2 and its basicity is 2 and its basicity is 2. Since its basicity is 2, so 82 divided by 82, 82 divided by 2, so that is 41. That is 41. So the equivalent weight of this H3PO3 is 41. We'll take one more example so that you can understand it in a better way. Fine. Now see, I'll take H3PO4. What this is? This is phosphoric acid. What this is? This is phosphoric acid, or you can say orthophosphoric acid. Now you should know the structure of this H3PO4. What is the structure of H3PO4? This is H3PO4.
सर जो नए सर आए थे उन्होंने बोले कि पहले हम फास्फोरस को बीच में लेना चाहिए, फिर OH लिख के डबल बॉन्ड O लिखना, फिर OH लिख के डबल बॉन्ड O लिखना बोल के बोले सर।
हाँ, नहीं नहीं, इस तरह से H3PO4 will be writing H3PO4 like this. This is the right structure of H3PO4.
ओके
See
सर।
here in this H3PO4, how many OH are there? 3 OH are there. So their N factor will be 3. There, this since this is an acid, so it will be having basicity. Acids will always have basicity and bases will always have acidity, contrasting characters. Now see, since it is having 3 OH, so N factor will be 3. So how you will be getting equivalent weight of this H3PO4? This equivalent weight is very important there in solution chapter. This equivalent weight there in class 12th. This equivalent weight will be very important there in your electrochemistry chapter. If you won't be knowing this equivalent weight, then there you won't be able to do numericals based on this all. So equivalent weight here is equal to, as we already have done this, molecular weight upon basicity. Because it's an acid, so you'll be writing basicity, and if it is a base, then you will be writing acidity. So molecular weight. Now, how you will calculate molecular weight? This is 3 plus 31. 3 plus 31. 3 plus 31. That is 34. And then 16 fours are 64. 64 plus 34 will be 98. So molecular weight is 98. And since it is having 3 OH, so 3 hydrogens are replaceable. Since 3 hydrogens are replaceable, so it is tribasic acid. It is tribasic acid. So N factor here will be 3. So 98 by 3 will be the equivalent weight of this H3PO4. So here, see, you should know the bonding also. You must be good in bonding also. Then only you can handle this topic. Otherwise, it's very difficult for us to manage. Since it is tribasic acid, so N factor will be 3, basicity will be 3, and to get equivalent weight, you have to divide molecular weight by 3. So that is 98 by 3. So we'll get the answer. That is approximately approx
2.6
Approximately it will be 3 threes are 32 points.
32.6.
Yeah, approximately. Just please check because I won't be using calculator. So orally I'll be doing, so maybe making mistakes. So just always please check. So this is one more example. Now I'll take one more example. So see here, see here, one more very important point here. Molecular weight is equal to 3 into equivalent weight. Molecular weight is equal to 3 into equivalent weight because basicity is 3. So basicity into equivalent weight is equal to molecular weight. So in this way, you can calculate molecular weight also. Now see, I'll take one more example to understand this concept in a better way. See, equivalent weight of HNO3. Equivalent weight of HNO3, you know what is the structure of HNO3? N is having three unpaired electrons. So this is 1, and here double bond O, and then nitrogen is having 5 electrons. One electron from this oxygen is shared, and here 2 electrons of this oxygen will be shared. Now octet of this nitrogen is all over. Now it can form only coordinate bond. See, this is HNO3. So that's a way, means this is what I am telling you again and again, that you must be good in bonding, then only you can handle this topic. This is advanced level topic, so obviously will be very crucial, not only in chemical bonding, but in solution, but in electrochemistry. So many more chapters will be touching this topic. So this is HNO3. Here there was only one H. So it is monobasic acid. What this is? This is monobasic acid. The basicity of this acid is 1. That is why it is called monobasic acid. Now see, to calculate equivalent weight of this HNO3, what you need to do, you have to do the same thing again, molecular weight upon N factor. What molecular weight is? Molecular weight of this HNO3 is 63. See, 16 threes are 48. 48 plus 14 will be 62. 62 plus 1 will be 63. So 1 plus 14, 15 plus 48. 15 plus 48 will be 63. So 63 divided by 1. So here equivalent will be similar to the molecular weight. In both monobasic acids, in monobasic acids, equivalent weight equivalent weight will be equal to, equivalent weight will be similar to molecular weight. Both will be having same value because N factor is 1, because basicity is 1, N factor is 1. So here equivalent weight will be equal to the molecular weight, and like this you can calculate some more compounds too, their equivalent weight too. See, HCl. What HCl is? Hydrochloric acid. This is 35.5. This is 1. So its molecular weight is 36.5. See, equivalent weight of this HCl. Equivalent weight of this HCl is equal to 36.5 divided by 1, because here there is no question of OH. Here there is no O. So on the basis of H only, you will say the N factor. How many H are there? Only one H is there. So N factor is 1. So 36.5 divided by 1 is equal to 36.5. So in this case also, molecular weight of HCl is 36.5 and its equivalent weight is also 36.5. So in this case also, molecular weight is equal to equivalent weight. In every monobasic acid or monoacidic base, molecular weight will always be equal to equivalent weight because their N factor will be 1 only. Now see, you can take H2SO4 also. You can take H2SO4 also, sulfuric acid also. Now see, in sulfuric acid, here Again, you need to draw the structure of sulfuric acid. See, sulfur is having 6 electrons. Sulfur is having 6 electrons. 1 electron of this oxygen and 1 electron of this oxygen. In this way, now sulfur will be having 8 electrons. After completing octet, an element can never form any more covalent bond, can only form a coordinate bond. So one coordinate bond with this oxygen and another coordinate bond with one more oxygen atom. Now see, here there is no question of double bond between this sulfur and oxygen because octet of this sulfur is already over. So after completing octet, no ionic, no covalent bond can ever be formed. Only coordinate bond can be formed. So this is H2SO4. This H2SO4 is having two OH groups attached to the sulfur central atom. So since two OH are there, so N factor will be 2. It will be dibasic acid. Its basicity will be 2. So if you want to calculate equivalent weight of this H2SO4, what you need to do, you have to write molecular weight divided by N factor. Molecular weight of this H2SO4 is
53.
98. 98.
53.
This 64,
Answer.
64 plus 32 plus 2. 32 plus 2 will be 34. 34 plus 64 will be
Yeah,
98.
yeah, yeah, yeah.
So 98 upon 2, that is 49. 98 upon 2, that is 49. In solution chapter in class 12th, this normality will be there, and in that normality, this equivalent weight will only be used. In molarity, molecular weight will be used, and in normality, equivalent weight will be used. And in Faraday's law of electrolysis also, there in electrochemistry, this equivalent weight will be used. In second law of Faraday's law of electrolysis, second law of Faraday's law of electrolysis, there this equivalent weight will be used. See, now what next is, so I already explained you about uh, valency. I already explained you about charge. I already explained you about the oxidation number. I already explained you basicity. Now I'll be talking about acidity. Now see, take one example, ALOH whole thrice. Now take one example, AL, ALOH whole thrice. ALOH whole thrice. In this ALOH whole thrice, how many OH are there? 3 OH are there. So N factor will be 3. N factor will be 3. This is
सर
tri.
ऑक्सीडेशन नंबर में H2SO4 में अगर वो ऑक्सीडेशन नंबर पूछेंगे तो हम हाइड्रोजन का लिखना, सल्फर का लिखना, ऑक्सीजन का लिखना।
C, which is least in number in H2SO4?
हाँ, सल्फर।
Sulfur. Sulfur is the least in number. So they will always be asking you whatever they will be asking you. If they will be asking you oxidation number, if they will be asking you hybridization, if they will be asking you charge, that can only be of central atom. And how you will decide which one is central atom? Central atom is not geographically central. Central atom means the importance wise which is central. In HOCl, here geographically as well as importance wise, from both way, sulfur is the central atom. So you will always be calculating everything related to the sulfur. Then what about HOCl? Here I told you the one which is least in number, the one which is least in number will be central atom. So since here sulfur was least in number, so was central atom. And what about HOCl? And what about HOCl? In HOCl, what is the center? Which one is the central atom? Here, C, all the three. H is 1, O is 1, Cl is 1. That central atom can never be hydrogen. That central atom can never be hydrogen. But then too our problem remains same. Oxygen and Cl both are same in number, both are 1 in number. So how you will decide which one is the central atom? The one which is less reactive, which is less reactive, which is less electronegative. How you will come to know about the reactivity? You will come to know about the reactivity of an element on the basis of their electronegativity. Oxygen is very highly electronegative, second most electronegative element. So it is second most reactive element. So this can't be the central atom. Then what is the central atom? Cl is the central atom. That's the best way to come to know about the central atom. First thing, what you should do, first, the one which is least in number will always be a central atom. Here, that least in number was sulfur, so sulfur was the central atom. But in HOCl, how you will decide which is the central atom? Then there you will be using second point, the one which is less reactive. The one which is less electronegative will be the central atom. So Cl, since is less electronegative, since this Cl is less reactive, so will be central atom. Now see, around this Cl, how many OH are there? Only one OH is there. So this HOCl is also monobasic acid. There also N factor will be 1. There also N factor will be 1. In this way, you can calculate N factor. So in this case also N factor will be 1. See, I was talking about AlOH whole thrice. Since in AlOH whole thrice 3 OH are there, so this is a base, and base means those which are having OH are called base. So this is a base. Base will always have acidity. So acidity of this will be 3, or you can say N factor of this will be 3. N factor of this will be 3. So N is equal to 3. So acidity will be 3. So to get equivalent weight of this AlOH whole thrice, what you need to do? Molecular weight divided by 3. What is the molecular weight? 16 plus 1, 17. 17 threes are 51. And aluminum is 27. So it is 78. So 78 divided by 3. 78 divided by 3. This is the equivalent weight of AlOH whole thrice. See, 16 is oxygen, 1 is hydrogen. So 16 plus 1 is 17. 17 threes are 51. And what is the atomic weight of aluminium? 27. So 51 plus 27 is equal to 78. So 78 divided by 3. This will be the equivalent weight of this aluminium there in AlOH whole thrice. So see, valency is over, charge is over, oxidation number is over, basicity is over, acidity is over. Then the last thing to calculate this oxidation number is one of the difficult most, and there you should know the balancing of the redox reaction. Then only you can understand this, otherwise it will be difficult. So obviously one by one, all topics can be covered, all topics can be explained, but in one day, overnight, it won't be done. Now, see, we will be taking KMNO4. This KMNO4 reacts with H2SO4 or HCl or HNO3, and what you will get? You will get MnSO4. This you need to remember. This you need to remember. Fine. Now see, will take, obviously what I am trying to tell you here, that will take time. It won't be. This I am explaining you, so this you will understand. But if something new, then it will be difficult for you to manage. Here, what is the oxidation number? Charge of this oxygen is -2. And how many oxygens are there? 4. So it is -8. What about this one? This is 1 plus. This is 1 plus. This is -8. So what about the Mn? Mn will be 7 plus. So here Mn is 7 plus charge. And what about the SO4? SO4 is 2 minus. So here Mn is 2 plus. So this 7 plus is changing to 2 plus. How this 7 plus can get converted into 2 plus? By gaining 5 electrons. Since in this reaction, KMnO4 gains 5 electrons to react with H2SO4 to form MnSO4. So that is why N factor here will be 5. N factor here will be 5. And if you want to write equivalent weight of KMnO4, equivalent weight of KMnO4 is equal to molecular weight of KMnO4 upon N. What is molecular weight of this KMnO4? Now see, potassium is 39, Mn is 55, atomic weight of Mn is 55. See, if in exams they will provide you these values, then it will be easy for you to handle. But if they won't be providing you all these values, then you should remember, otherwise you won't be able to solve questions. What about oxygen? Four oxygen atom, one is 16, so four will be 64. So 64, that is 5 plus 4, 9 plus 9, 18, 8, carry over 1, 3 plus 1, 4, plus 6, 10, plus 5, 15. So 158. Now see, to get equivalent weight of KMnO4, 158 divided by what? Divided by 5. So it will be 5 threes are 51, 5 ones are 5. So 31.6. Just please check whether I have done this calculation right or not. So 31.6 will be the equivalent weight of this KMnO4. Once again, see what is the charge of this Mn in KMnO4. How we will calculate this? Oxygen is -2, 4 oxygen atoms, so -8. K is 1 plus, so -8 plus 1 will be -7. So this Mn will be 7 plus. And when this KMnO4 reacts with H2SO4, product formed will always be MnSO4 since SO4 is 2 minus. So Mn will be 2 plus. So the 7 plus is changing to 2 plus. How this 7 plus can get changed to 2 plus? By gaining 5 electrons. Since in this reaction, this Mn is gaining 5 electrons, so N factor will be 5. So to calculate equivalent weight, what you should do, you should write molecular weight upon N factor. Molecular weight is 158. I have calculated it here. Molecular weight is 158 and N factor means that is number of electrons lost or gained, that is 5. So 158 divided by 5, that is 31.6. So here equivalent weight will be 31.6. I'll explain you some more examples related to this KMnO4 so that you can understand it in a better way. See, if this KMnO4 reacts with H2O, that's neutral, then you will get MnO2. This products you should remember. Obviously will take time. Right now you do not know, so it won't be easy for you to handle. But like this, I'll keep on telling you, and this way you'll learn this all. Now see here, Mn is 7 plus, and here Mn is 4 plus. So this 7 plus is changing to 4 plus. This 7 plus is changing to 4 plus. How that can be done? By gaining 3 electrons, this can be done. Now see, equivalent weight here is equal to molecular weight that we have already calculated is 158 and N factor here is 3. So 158 divided by 3, so it is 52 point something. Just please check whether it is 52.6 or not. So this is the equivalent weight when
No, sir,
came in.
31.6.
No, no, 3 5s are. This is divided
158
by
by
3.
3.
Yeah, divided by 3. Why 3? Because 3 electrons are added. It was acidic medium,
Ah, okay,
so
okay,
it was
okay.
acidic medium. So there it was 5 electrons. This is
Okay, okay.
neutral medium, so it is 3 electrons. In uh, basic medium, it will be 1 only. That also I'll explain you. This is what I am trying to explain you, what the use of this N factor is. If N factor is different, then the same compound will be having different equivalent weights. So there, since why you have divided molecular weight by 3, you have divided molecular weight by 3 because in this reaction only 3 electrons are added. How we can say 3 electrons are added here in this reaction? Because see here in this compound KMnO4, Mn is 7 plus charged and here MnO2 will be formed as I was talking about N factor, as I was talking about N factor. So I explained you KMnO4 plus H2SO4, that is acidic medium. KMnO4 in acidic medium reacts with H2SO4 to form MnSO4, and here Mn is 7 plus and here Mn is 2 plus. So since 2 electrons will be gained here, sorry, here 5 electrons will be gained.
Sir,
So equivalent weight. equivalent weight is equal to molecular weight upon n factor, that is 5. So molecular weight upon 5, and you will get equivalent weight. This is one thing in acidic
Sir,
medium.
if OH is there, if OH is there, then it is basic medium, sir.
Yeah, H2SO4 is acid now. So it
Oh,
is
okay, okay.
acidic medium. H2O is neutral,
Mm.
so it is neutral medium. And KMNO4 plus H2O. In that case, what product you will be getting? You will be getting MnO2. See here, Mn here, Mn is 7 plus and here Mn is 4 plus. So here 3 electrons are added. So equivalent weight is equal to molecular weight divided by 3. To get equivalent weight, you can divide molecular weight by 3. Now see, acidic is over, acidic is over, acidic medium is over, acidic medium is over, neutral medium is over, basic medium is not done. So now we'll do basic medium. Basic medium means KMNO4 plus KOH plus KOH. See here, OH is there, na? That means basic medium. Now, what will be the product there in this case? K2MNO4. This you should remember then only. If you don't remember this, you can't get N factor. Now see here, here Mn is 7 plus and here Mn is 6 plus. How we can say it is 6 plus? This is minus 8 and this is plus 2. So minus 8 plus 2 will be minus 6. So this Mn is 6 plus. So 7 plus is changing to 6 plus. How that can be done? By gaining one electron. So here equivalent weight will be equal to molecular weight upon 1 because n factor is 1. How I did this? You know, in bio, we have done DNA, RNA. In bio, 9/10 we did DNA, RNA. So here, to remember this, what you should do, you should know PNA, that is basic, neutral, acidic medium. Basic, neutral, and acidic medium, they are in case of KMNO4. N, sorry, N factor there in basic medium will be 1, in neutral medium it is 3, and in acidic medium 5. So this is what I do. Since I know what are the N factors there in basic medium, neutral medium, and acidic medium, that's why it is easy for me to remember about the products. So that's the way. This is all about N factor. So valency is over, charge is over, oxidation number is over, and then acidity of a base is over, basicity of an acid is over, and number of electron lost or gained during any chemical reaction is over. So in this way, all the 6 points related to this N factor is over. So that's a way to calculate N factor. That's a way to calculate N factor.